Good afternoon. We find ourselves in the shop that you guys are probably missing like crazy. And that, I understand, which is why I find myself here as much as I can, because I love it here too. So what we're going to do today, we're framing in a window in this open space right here. On the Friday, we'll do the door over here. That'll be a lot of fun for the Friday, so you can tune in as a refresher for all the different components. We'll do the door. Maybe we'll even do it live. In fact, I think we will do it live at, we'll say 11 o'clock on Friday. But in the meantime, we've got this open space. So what I've done is I've trimmed the inside of this opening with 2x6s. So you can see what I've got here. There's 2x6 here, 2x6 up at the top, and 2x6, and it defines the opening. So we're not going to talk too much about building from scratch like as though there's nothing. We're filling in a hole. So imagine that you have an archway at your home, and it's kind of just wide open between the dining room and the living room, and you're like, you know what, maybe I've had enough of this not working, but I've had enough of the open concept. What I'd like to do is I would like to close in this opening and have more of an intimate living room and more of an intimate dining room. So you want to build a wall in an existing opening. Now, that takes us to where we are right now. So I've got this outside trimmed in. Now we have something to actually screw to, which is the number one reason that I did this, is so that we would have something to screw to. Just for a quick second, what I'd like to do is I'd like you to look down, and what we have down below, if you'll remember, is the cinder block wall. Now remember the cinder block wall on the top. Just for instance, let's just think about how we would fasten a wall to a foundation, okay? So here's the way it would go. Foundation wall, we talked about the 4 different types of foundations. That's okay. Once you have your foundation wall and you've leveled the top of your wall all the way around, because you don't want your wall sitting like this. You want to build square walls put up on top of a flat and level platform. So there's leveling compound and cement, and there's shims that you can use to level the top of this concrete, on top of which, or cinder blocks by the way, on top of which you put your sill plate. Now this is that pressure treated piece of lumber that comes in contact with the cement. So it's pressure treated because we don't want it to rot. We fasten it to the top of this cinder block wall with that threaded rod, if you remember. Because remember that what we talked about, whatever your foundation is, your house is literally bolted to your foundation. And it's not going to stop your house from being lifted off. It's mostly stopping it from sliding side to side. More than strong enough to do that. So it's pinned all the way to the top of the foundation wall. And we remember how we buried the pieces of threaded rod that were in the shape of a J into the cement if you had a poured concrete foundation, or in the open holes of a cinder block foundation, you just pour concrete and you submerge those threaded rod J hooks into that liquid cement, let it sit, and then you've got those rods sticking up, just like the nails were sticking up out of your cement in the top of your mini houses. We did the same thing there. So this now allows us to put a sill plate. The sill plate on top of that, we would then put a flooring system, which you did on your mini houses, okay? So that's just a refresher on how to get everything situated and set level on top of your foundation wall. What we are working on now is we are treating this sill plate as though it is the deck, the floor in your house. We are just building a wall on top of that. So let's angle the camera back up just a smidge. All right, so we're back to our opening, and we've got something that we can actually screw to. So we have to talk about the components of a wall. You looked at the PowerPoint yesterday, or you should have, and we now know that there is a lot of different components. Now there were 12 different answers, and there are multiple types of studs. There's a couple of types of plates that you use. We're going to start with the 2 plates, the bottom plate and the top plate. We are building this wall piecemeal, okay, in place in the opening, for a couple of reasons, but we won't go into that right now. But the reason we're building it piecemeal is just, we can do it one step at a time, and we can have a conversation about it. What you would do if this was building a house, you would build the wall laying flat down according to your blueprints, and then you would lift it up into place. I mean, there's no hole that you're putting a wall into, so it's free wide open. There's nothing stopping it from being lifted into place. And that's the fastest way to do it. It's the safest way to do it, because if you're trying to put a top plate on, you're on a ladder, well, that's a pain in the butt. But if you're building it on the floor, firm footing, you're not gonna fall. So it's a much safer way of doing it. You get multiple people lifting a wall into place, and then we get to building one wall, then another wall, meeting at a 90, and now we can think back to, well, how do we make sure that those walls meet at a 90 degrees? 3, 4, 5 is all I'm gonna tell you, all right? So, that being said, let's do this stick frame of this wall. We are going to build it as though it's the exact same type of wall that builds up with 2 top plates and a bottom plate. So let's begin. So this bottom plate right here, this one spans across all of the studs. If it was an ideal situation, think of the flooring system. This bottom plate is going to have the entire wall pressing down on it. Now, this is not a structural wall, but just think of it as a structural wall, because that way we can really start thinking about the 4 forces and how they interact. So I want you to remember the 4 forces. Look to the side of the screen right now and you'll see a detail of the 4 forces. There's the bending, torsion, compression, and tension. Those 4 are always needing to be contended with. So building this according to, to specs and to the building code will work just fine at counteracting the effects of the distortion effects of those 4 forces. So here we go. This bottom plate will have all the weight pressing down on it, being distributed across the length of the floor system, and hopefully it would have the floor joists going like this. So the 2 types of force that are being exerted on this bottom plate, or the sole plate, are compression, because it's trying to squeeze it thinner. Very good at resisting that because of the actual makeup of the pipe. The other is any vertical stud that's pressing down on that sole plate is trying to bend the wood in between the structural support of the floor joists that are underneath. But again, because of how they're spaced out, 16 inches, they have a lot of strength and a lot of resistance to the bending force that's going to be applied across 16 inches. Pretty strong, very short distance. Again, that's another reason why the spacing standards are very important. So, sole plate's gonna take that weight. Then we move to the top plate. The first top plate goes right on top of the studs, okay? Well, we have to finish talking about the plates. So the top plate is going to bridge the gap for everything that is overhead pressing down, is going to connect all of the studs, holding them in place vertically, and it's going to take the weight of the roof on top. It's also spanning across, so it's distributing the weight of all that force pressing down, resisting the same 2 forces that are being exerted on the sole plate, the compression and the bending. Okay? But you may have asked yourself, what is the purpose of the double top plate? What's the second top plate for? Well, you're not going to have 2x4s 30 feet long. So if you're building a wall that is 30 feet long, that is 20 feet long, well, you're probably just going to build them with 8-foot 2x4s, maybe 10s or 12s, but it's not reasonable to use 20-foot 2x4s just to stop from having a seam, a joint, where one 2x4 ends and another one begins. So the reason we have the double top plate is because the weight that's being kind of exerted on that double top plate, we can't have any of the weight being pressed down at a joint. There's no strength there. There's no resistance to bending. So what we do is we have a joint there, and then we have another, let's do this. And then we'll have another piece of wood where the joint does not match where the joint is on the first top plate. So it kind of staggers the joints and adds additional support. The overall height of your wall has to take into account the bottom plate, the length of your stud, the top plate, and the double top plate. That's the height of your wall. So make your calculations thinking of all those things, okay? So we've got our double top plate, our single top plate, and our sole plate in there. Fantastic. So now what we have to consider is, what are we going to do for how far apart we space our studs? Because the studs, thinking that this is a load-bearing wall, meaning it's taking the weight of everything above pressing down, we have to make sure that the studs are spaced far enough apart to be reasonable, but not too far apart to allow the top plates to bend. So that is, going back to our standard, to our the Ontario Building Codes, is 16 inches on center is the most common, but there are two more types of, there are two more spacing standards that apply to floor joists and for studs and ceiling rafters as well. One of them is 16, which is the one we're going to use. There's one that's smaller and there's one that's larger. Look to the side of the screen and you tell me what the other two are. Okay, now, we now know that it's 12, 16, and 24. We're going to use 16. So what we've done is we have taken our tape measure and we have marked from the side of the wall, which is the very first spot where we're going to have drywall meet. So we will drywall this wall in the next coming week, but the drywall is going to start here and go that way. So the edge of the drywall to the opposite edge of the drywall is 48 inches. And remember, that was the other reason that the 16-inch on centers, or 12 or 24, are important to adhere to. Because once you reach the end of a piece of drywall, you have to be at the center of one of the studs. Be it a stud that's spaced 12 inches apart, 16, or 24. If they're spaced like that, starting at 0 to the edge of the wall, going to the center, to the center, to the center, you will reach 48 inches and be right in the middle of a stud. It's very important. So what we've done is we've marked over center, 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 and we've done the same at the top as well. Now, when we framed in this, we had to make sure that this was square. There's nothing worse than trying to work on a wall that's not square. So we've got the center line marked at the top, center line marked at the bottom. So if the bottom and the top are centered on the stud, we know the stud's going to be level. We can also take the level to do that. So here's what I'm going to do. I'm going to put these studs in place. But remember, we're framing in a window, so we'll have to have an opening, which means we're going to remove one stud. I got a specific window that fits perfectly between two studs. It's kind of a standard. I'm sure that they're quite common. So we put this in place. Don't fall down. I'm on camera here. And we would not do this with screws. The reason we would not do this with screws is because that's not the code. Not these particular screws anyway. I'm sure you could find screws to do it. Two reasons why you wouldn't use these brass thin screws. They're not strong enough, so they don't meet code, and they take way too long. So when you're framing, you generally don't frame in the expectation of taking it apart. So when you put your fasteners in, your mechanical fasteners, you don't want them coming out. So by your design or by accident, especially by accident. So you'd use, like a nail. Nails go in faster, especially when fired from a gun. I'm just putting them up with screws because I'm going to do this over and over again. So a couple of screws. That's one. Second stud. Well, let's be honest. I needed the exterior frame, so the second stud's already in place. That's this baby right here. Now these are called common studs. If you remember from yesterday, the different types of studs that exist in a wall, there are, I believe there were 4. There was a common stud, there was a king stud, there was a jack stud, and there was a cripple stud. Let's go through them. These are, what do you think this one is? We're not framing anything yet. Look to the side. These are common studs. So I'm going to put this one up right where I need it to be. Don't fall. Like I said, I'm on camera. Woo, I'm so nervous. Okay, the other stud. It just so happens that sometimes, especially with the window that we have, the common stud falls exactly where we need it to fall to serve as the other kind of stud that defines the opening of the door or window that you're putting up in that other stud is called the king stud. So in this case, our common studs that fall at those specific spots actually are serving as king studs. So they're doing dual duty. Now we've got those studs up. Now, what we have is a window. Now this window right here measures 30 inches. So we have an opening here that we have to frame in. But what we have to take into account is the weight that is on the top, over top of this window, cannot rest on the window. It cannot. The window can't handle it. So what we have to do is we have to take the weight from the window, pressing down, be supported by something very strong, and be supported by two studs that support that header. Now that header is a beam. That beam for us is made of LVL, laminated veneer lumber. Now, it should be the same width as the 2x4 wall. We're only putting up one piece, so if you notice that, don't worry. I'm only going to put it up for appearance sake. So what we need to do is we need to frame in an archway. That's what we're doing. And an archway takes the weight across the header, distributes that downward pressure, transfers it to the two outside studs, which are called what? Jack studs. Yes, that's right. They're called jack studs on the outside. So the weight presses down from the top, supported by the cripple studs on the top, pressing down on the header, across the header, down to the jack studs, down to the sole plate or the bottom plate, and is supported by the floor system. And all that downward pressure goes around the window. That's what these archways for framing in windows and doors are for, is for taking the overhead pressure and sending it around the structures that need to be opened and closed or are made of glass. So what we've done is we've cut all the pieces to make the arch. So here's the arch. And the arch is made of two jack studs, which I will fasten in place. Don't you fall. Two jack studs, which I will fasten in place with a couple of screws each. One. And a two. And two more. Okay, that's a one. And that's two. So now we've got the jack studs in place. But now we need something for the overhead to press down on. Now remember, this LVL, laminated veneer lumber, is engineered wood. The two different types of lumber that you can use are milled lumber, which is 2x4s, 2x6s, and stuff like that, that has growth rings and the potential for warpage. And then we have engineered lumber. And there's a host of different engineered lumber. This one is like plywood, but this is 2-inch thick plywood. So we have a lot of opportunities with this LVL. I mean, aside from the projects that I've been making, like countertops. But this stuff will take this bending force, which is the number one force that it's resisting, because the roof is pressing down, the second floor is pressing down on this, and because of the strength and because of the way it's manufactured, it has an enormous amount of resistance to bending force. Okay, it's also being compressed, but well, there's so many different layers. How plywood is manufactured, I'm going to be posting a video to the right. Take a look at to the right now, and you will see a link to a video that details how plywood is made. This is just super thick plywood, okay? And you can take a look at that. That's very interesting stuff. So anyway, this goes on top. This serves as the top part of the arch and goes right in place right there. Well, it will as soon as it decides to listen. Oh, let me adjust something very quickly here. There we go. Now, we've got our header. Another word for header that was detailed in the PowerPoint presentation, I would like you to tell me what another word for header is. The header that goes across the top of a window arch or a door arch, because you'll have the same thing for a door arch. What's another name for it? It's called a lintel. And I'm sure there's the etymology of that word, which goes back a long time. So I'm going to fasten this in place. One. Now, if you were here, we talk about the thickness of that, because we know a 2x4 is 3.5 inches wide, but that piece of LVL right there is only 2 inches wide. So we have to actually build it up. So we would layer two pieces together until it spanned all the way across. But again, this is for show. All right, so now we have our arch, but we still have nothing supporting over top right here. So what we have for that are these type of studs, and these are very short studs that act as a support that will span the distance over top of that header, taking the downward pressure from the overhead floor that's pressing down. It will support that, transfer that downward pressure to the header, which would take that, transfer it over to the jack studs and down to the floor. These act as crutches, which is why they called them cripple studs. Okay, so let's put this in place. We've got one. Oh, we're gonna have to do some convincing of the wood. Oy, oy, oy. There we go. Well, when I put this together in the first place, these fit perfectly. So if you'll bear with me, I am going to have to go and shave a little slice off of here. But I'm not going to pause the video. Stick around with me. You'll hear the scream of the miter saw. I'm back. Let's put this in place, see if it fits. Ah, snug as a bug in a rug. That's one. That's two. And that's three. And we are going to put a stabilizing screw in there. And I want to talk about why I just called it a stabilizing screw. It is not a structural support screw. Don't tease my belly. I worked hard to get this. So it's not a structural support screw. Go hold that there. The reason it's not a structural support screw is because it's not, or the nails wouldn't be. The nails have a lot of strength, but they're not there to keep the house up. There's something that you really need to come to understand, and it's the purpose of a mechanical fastener in the case of framing is not to hold the structure up. It is to hold the individual pieces in place. Okay? It's very important. We'll go into detail about that in just a few minutes because I want to finish putting this wall up. So now we've got the arch. The overhead weight pressing down is going to press down on that header. That header will then have the weight transferred from the top of the header to the left and right side, carried by the jack posts. So the weight presses down here, it goes to the header, transfers over to here, presses down, and then down to the sole plate, down to the foundation, through the flooring system and the foundation walls. So it's the weight pressing down, and it just kind of skirts around all the soft and fragile openings. That's the way it works. But we still have to put the window in place. So in order to put this window in place, basically, we've just framed in a door. That's what a door would be. And what we would do is we would then trim the door in with nicer looking materials, like a piece of plywood that's got a nice finish to it. We'll talk about that in grade 11 when you come back. And that opening is just slightly larger than the door. We have a frame that the door sits on. And when we would frame in this door, we would frame in an opening just like that, just larger. Then this nicer looking wood, okay, goes in place in that opening. Of course, the wall would be trimmed all the way around just like that, and then the door would be hung on the hinges and they would open and close. That's the way a door would go. And tune in Friday when you want to see, if you want to see that happen. But a window is just something that sits in the same archway opening as a door, but it just fills the space in a different way. There's no weight pressing down on it whatsoever. So what it sits on is something like this. Okay, we've got this here, which is one of the definitions. Can you remember what the window sits on? What's the name of that? Look to the side of the screen. That's right, it's called a sill plate. But it sits on this funky little thing here. This goes in place. Looks like I need to make one more small adjustment. Well, let's do this. Looks like I made the adjustment in the right spot. Good. There. All right. So you measure across the opening. And the opening is just slightly larger. The rough opening is just slightly larger than the size of the window or the door. So you put this beautiful little thing in place, screwing it together to hold the pieces in place. And remember, this does not take a lot of weight. It just takes the weight of the window. The windows are made of glass and fiberglass. So you do not have to worry about a lot of crushing force coming down on this. So I'm going to hold the center stud in place. Now you may ask yourself, why then, if it's not a lot of weight coming down on the window or coming down on that window sill, why do we need this jack stud, or not jack stud, why do we need this stud right here, this cripple stud? Well, there are two reasons why we need to have those studs. The first reason is if it does, in the case of the one over top of the header, this is taking a lot of weight. So it has to be there to transfer the weight that's pressing down to the header. This one here is not taking weight, but we still have to fasten the drywall to something, don't we? And we want to make sure that our studs are evenly spaced at a regular interval, so that as a drywaller, you're going to put the drywall up and expect a stud to be there because, well, it's 16 inches from the last screw, so in it goes. And something to be said, something to remember back, the nailing or screwing schedules. That means when you're putting a sheet of plywood down for a floor, or wood up for sheeting on a roof, or drywall up, there is, according to the building code, a minimum number of screws that need to be put in place to hold sheet goods in place. They need to be of the right kind, they need to be spaced right, and they need to be so long, and it's all detailed. And as you become a craftsperson, you understand these things to be just normal, commonplace things. You don't have to go look it up. But that being said, that's the other reason why this stud has to be here. Would the window bend and distort if that wasn't there? No, not at all. But there'd be nothing to screw the drywall to. And very possibly, you may want to have right below your window, I don't know, have you not seen electrical outlets right below a window? You'll have to screw it to something. It can't just hang off the drywall. So electricians will come to understand that, oh, I can always put another electrical box there because, well, I know that there's a stud there, so 16 inches later, there'll be another stud. So now we have the window framed open. Are you as nervous as I am that this is not going to fit? Ha! Here we go. So now, one question I want to ask all of you is if you take a look at the windows where you live, what do you think is holding those windows in place? Since there's no weight on the windows, then the window doesn't have to hold anything up. The window just has to be held up. And it may surprise you to know what it is that's holding up your windows and holding them in place. Probably no more than 4 screws. That's it. Other than that, it's the capping and the siding and the materials outside that decorate your exterior house and protect it from weather, and the trim on the inside. So, like I said already, the opening for the window is called a rough opening, which means it's kind of close. It's a little bit bigger because you don't want to be forcing a window in. You want a little bit of play back and forth. But when you put this up, it's got to sit in there. There's very little space, but it's kind of interesting. Sometimes the space that you have between the window and the rough opening is good to have a decent amount of space. 1/4 inch, something like that, maybe even a 1/2 inch all the way around, because then you're going to pack it with insulation. Now it has to be big enough, low power mode, it has to be big enough for it to fit the window, but it also has to have a little bit of a gap, enough for you to push in some fiberglass insulation or put in the nozzle for spray foam insulation to go all the way around to seal up those air gaps. But before you do that, I have to get something very quickly. And what we have is our version of shims. Usually they're made of cedar. And what we do is we get a stack of shims. We go from one side to the other. We just cut a bunch of them. They come in packages of just wedge-shaped pieces of wood. Cedar is the #1 choice because it doesn't rot when it gets wet. It's got a lot of resistance to that. So you just wedge a few of the shims in there. Let me break these in half so I can do both sides. Wedge some shims on one side. Then you wedge some shims on the other side. And you can go back and forth and back and forth and adjust the window, and it's held in place by those shims, frictioned. Then after you've got it perfect and level and pushed out just enough, because you have to position it in that opening to account for being flush with the drywall when you're finished, and then on the outside for the window capping and the finish work and the sill outside. It's a whole process of multiple trades working together. So positioning of the window front to back and making it square, making it level, not too tight. So once you get it all nice and secure and in place, let me just wedge the top in there. So I want to show you guys what happens. You wedge the top in place. Sometimes it takes a lot of shims, and that's okay. And this gap that's here will be filled with spray foam insulation. I've got some at home, and if you haven't seen it, maybe I'll bring it in tomorrow and I'll show you what this stuff does. It's really cool. It's a chemical reaction. It's liquid when it's under pressure, but when it's out and it's mixed, it fluffs right up. But it's an airtight, watertight seal, and it's fabulous insulation. So anyway, once you got your shims in place, your windows in the right specific spot, you break these shims off, fill it full of spray foam. But before you do that, you take a couple of screws on each side. I'm going to adjust this window to allow for the drywall. We're going to take a couple of screws on each side. One and two, and that's it. Even your big picture window's probably got 6. No more than that. Take a look inside. of one of your windows. There we go. And there you have a wall, very small, simple wall built, and a window framed in. And remember, the entire process of framing in a window is to take the overhead weight and distribute that weight around the window using an arch. And remember the components. So the compression of overhead, these cripple studs are being compressed. They're excellent at resisting that. The header is being compressed and it's attempting to be bent. Excellent resistance to that. Remember the plywood manufacturing video you just watched. The cripple studs down below, they are supporting the compressive weight of the window on it, as little as though it is. It's like your little baby cousin sitting on your back. Yeah, it's wearing down on me, but I can take it. Jack studs. Jack studs are taking a lot of compressive force. All the overhead is being transferred around the window and pushing down on those. We're not pressing down, but trying to make them shorter. They're not going to get shorter. The king studs, same thing. Standard studs, same thing. They are taking the downward pressure, the gravity that is having its way with everything above us, pushing down. So anyway, I think we're beating a dead horse here. So we've got compressive strength, we've got bending strength, we've got tension. Nowhere here. I don't see any tension. If you really wanted to go into detail, the only tension that is in here, and you may think on this, it's not required right now, but think on this, the only tension that exists in this entire wall is the bottom half, or the bottom third of this header is trying to be pulled apart. And if you can wrap your head around that, you're well on your way to understanding how these forces are working. The compressive strength, you know what? I'm going to stop there. I'm not going to go into too much more detail, but that in a nutshell is framing in this window. I hope you enjoyed it. Leave a comment and let me know, after you finish the homework. Show up on Friday after you've watched this video. So now it's time for me to upload this video and add the questions that you know were coming.